All right, so we are going to talk about serverless. First off, my name is Martin Omander, and I'm a developer advocate working in Google Cloud. And thank you very much for having us here today, everyone. So serverless, we're going to talk about serverless. I'm going to talk about why you would do serverless. Just a quick overview of what serverless is as well. Many of you know already, but just to make sure we get our ducks in a row and we agree on what is serverless. And then I'm going to mention some customers, real life customers, and what they are doing with Google serverless and what they have accomplished. And then we'll also go through some real life, some architecture of how I would build different types of applications with serverless. And hopefully the kinds of applications that you are thinking of building or that you are running right now, hopefully those types of applications will be the ones that I talk about in the architecture piece. So first of all, why do we do serverless at all? And here we go. So when I build stuff myself, I want serverless because it auto scales, it is fully managed by Google, so I don't have to deal with it myself. And it allows me to build stuff faster. Speed to market is faster. And later on in the presentation, we'll see some actual numbers from real life customers, what they have accomplished. So for example, auto scaling, this is just a hobby app of mine, but it got, 2 years ago, I had 1,000 users per day. And last week, with everybody being cooped up in their houses, my app had 2 million users in a day. And I had to change 0 to make that work because of the auto scaling of serverless. Now, what is serverless? So here, if you're building on-premise, you have to deal with physical security, you have security guards, that sort of stuff, network hardware, all that stuff. So if you have on-prem systems, you have to do something, you have to deal with all the boxes here. Now, if you go to the cloud, of course, when you know this, then we can skip the yellow boxes, which is great. Somebody else takes care of the yellow boxes. We still have to deal with all the blue and green boxes though. And that's five boxes. We would like to deal with fewer than 5 boxes. So by going serverless, we can skip the green boxes as well. So what you focus on, what you can focus your team on is building, developing the app, and then monitoring the performance of it. That's it. And an analogy that I've heard coworkers use is if you want a custom house, and custom house, nothing wrong with that. For many people, a custom house is the right thing to do. You can get the site plan exactly like you wanted, the floor plan. You can choose where your lot is, and you can choose all the appliances and fixtures and so on. But that is not all of us live in, not all of us want to do this or have the resources to do this, or not all of us can be bothered with this. Site plan, maybe there is a lot already that is in a good place. Just use that lot. Maybe the house on it already has a floor plan that works for you and your family. That is, with serverless, you can then focus your time on the furniture, appliances, what to watch on TV, and not do this full big project of building everything by yourself. Now, as we heard Alan talk about earlier, and Brian brought this up too, there are, for serverless computing, in Google Cloud, you have 3 products: App Engine, Cloud Run, and Cloud Functions. I'll go into a little more detail about what these do, but basically it's like App Engine is for web applications. Cloud Run is if you want to do web apps, but you like containers. Personally, I love containers. I'm a recent convert. About 1 year ago, I didn't know anything about containers. I started using them a year ago. I love them because they make deployments much safer. So if you want to write web apps with containers, you use Cloud Run. And if you just want to have simple event-driven logic, like if this happens over here in my system, then run these 5 lines of code, then you use Cloud Functions. All right, so App Engine, yeah, this is, you can write in these languages, and you have all kinds of built-in stuff for web applications. And Cloud Run, here you have the portability because you have containers, right? Containers are great. And it also means that you can use any language and any library. So for example, just for fun, a couple of months ago, I got into COBOL. I've never learned COBOL in school. I've never had a job where I programmed COBOL, but I wanted to tinker around with COBOL for a bit. And I was able to get that running in the Google Cloud because Cloud Run supports any language. And the Cloud Functions, again, triggered by an event, simple code. So this is kind of like your, sysadmins. They've always written these little scripts, like 5 to 10 to 20 lines of code, little shell scripts that, when this happens, do this over there. That is where Cloud Functions shine. All right, so that sounds great, but is anybody actually using this? And what are they using it for? Let's have a look. So there's a company in Europe called MediaMarkt. For those of you calling in from the US, you may not have heard of this company, but the way I think about it is kind of the Best Buy equivalent in Europe. So Best Buy has about 1,000 stores in North America. MediaMarkt has about 1,000 stores all over the European Union. Similar number of employees and revenue and such. So they sell electronics, and they have been over the last, let me start from the beginning. They started, of course, with on-prem systems, right? Because MediaMarkt, that was founded in the late 70s, they started with 100% on-prem systems. And then over time, they realized that they needed to go to the cloud, and they've been gradually moving stuff into the Google Cloud. And this has been accelerating. And they use Google Kubernetes engine. They love Kubernetes. It's great. They've done many of these projects now when they moved the on-prem workloads up into the cloud and Kubernetes. And a typical project, when they move something, looks kind of like this. So the boxes here represent just relative effort of getting a new project started. So this is after actually writing the code. What does it take to deploy this new application? And they do this all the time. And they do this often enough so that they have some really good metrics on what it takes. What are the steps? They go through these steps every time they deploy something in the cloud. And this is not too bad. This is faster, much faster than deploying on-prem. So they were really happy with that, deploying on Kubernetes. But then a couple of months ago, they decided to, this serverless thing, we've heard that things are faster on serverless. Let's actually, now that we have good metrics for our other cloud apps, how long it takes to deploy them, let's take a look at what it would take to deploy a serverless application. We'll do one app as serverless. And they did, and it was 8 times faster because there's just so many fewer things they need to set up. So in their case, they had 3 engineers working for 2 days. They took this app that they built, containerized it. So they now have the option of running this either in Cloud Run, totally serverless, or deploy this in the Kubernetes cluster if they want to, because Kubernetes runs containers. Or it's containerized. So, I hope they don't do this, but if they ever feel like Google Cloud is not right for them, they can pick up the container and leave and deploy the container at some other cloud. And this new app, this one app that these 3 engineers built, it gets 5 million requests per day, and they're really happy with the latency. And they're really happy with the cost too, 500 euros a month to serve these 5.5 million requests. And this is because, of course, when you run serverless, you don't need to decide ahead of time, like, I need, 20 servers and pay for all those 20, whether they are busy or not. Google Serverless just scales up and down for you. So you actually pay per request instead, which oftentimes works out to be cheaper, because MediaMarkt their users are mostly in a couple of time zones, European time zones. In the middle of the night, they don't have much traffic, so there wouldn't be any, it's not useful to have a bunch of servers, idle servers sitting around. That would just cost them money. The next example is actually not a company, but a non-profit. This is a non-profit that if you have kids of school age in your house, you may have seen this company, this non-profit in your house recently. I know I have, Khan Academy. My daughter was actually checking out a video on Khan Academy just yesterday about quadratic transformations. I'm not sure what it is, but I'm sure that the folks, the excellent people at Khan Academy explained it very well to her. So they, of course, seeing a lot more traffic now that everybody's stuck in their houses. But even before the COVID situation, they had seen traffic grow exponentially. And I know certainly in my kids' schools, middle school and high school, Khan Academy is becoming a larger and larger part of the regular math curriculum. So Khan Academy, they're actually, yes, it's kind of fun. They're not far from here. They are about 2 miles from where I'm speaking right now. I'm in Mountain View, California, and they are 2 miles in that direction. They founded by Salman Khan. He was, his cousin was actually having problems with math. So he just sat down over video conference and drew some pictures and doodles and tried to explain math to his cousin. And then others started hearing about these videos, and more people tuned into them. And eventually he started posting his recordings on YouTube. And then more and more people tuned in, and he started building a website around it. And a year in 2009, he quit his regular day job and started Khan Academy as a nonprofit. And now over time they grew, and they now have over 2,000 educational videos up there. And of course, this is fine if you have like 2 or 3 videos. You can just cobble together your HTML for that pretty easily. When you get to 20 or 30 videos, you maybe start needing some sort of system to manage them, a dynamic website. They've created that. When you start getting to 200 videos, you start getting other scalability challenges. When you get to 2,000 videos, now you really need to start scaling, and you get millions of people coming in and following and you have quizzes and all this stuff. And they noticed that their sort of homegrown system couldn't handle the scale. And they were spending too much time just scaling out servers, restarting servers that went down, all that stuff that they didn't want to do. So for them, App Engine was the right solution. They wanted a single platform that could house all the videos, and they didn't want to deal with server maintenance. Because after all, the Khan Academy folks, they are great at explaining math to kids and history and English and all kinds of other subjects. Their secret sauce isn't that they're very good at maintaining servers. So they moved to App Engine. They've been very happy. They tell us with their move. They can support a lot of visits. Actually, this is an old number before the pandemic hit. I'm sure it's far greater now. What they like about serverless is that their developers can now spend 99% of their time developing the app, working on the application. Because otherwise you spend maybe 50% developing your application. It's kind of like every developer you have is half a developer. By doing serverless, they can move faster. So having talked about 2 customers, let's talk about some real use cases here. Some technical architectures. So if you're building a web app, just a web app, you don't want to deal with containers, then App Engine is probably what you want. This is what Khan Academy did, right? If you're writing something where you want containers, it could actually be a web app, or it could be HTTP services, microservices talking to each other maybe, or web mobile backend or internal APIs, REST APIs and such. Cloud Run is great for that. it is container-based, and that's what MediaMarkt really liked about Cloud Run. A wide number of use cases for that. And then Cloud Functions is more of the sort of orchestration, workflow, and automation kind of use cases. Or just connecting, you know, this database over here needs to talk to this application over there. Just put some glue between them. That glue is called Cloud Functions. All right, let's zoom in here on the web app use case a little more. So here's one way you can do it. You could use Cloud Code. So this is a plugin you can download for IntelliJ or Visual Studio Code. You can, if you want to, you can build it using Cloud Build. That's like a build service in the cloud. You don't have to use that. And then you would deploy it on App Engine. So zero config deployments, you can deal with those spikes in traffic. And you can use code or build or skip those steps and use your own stuff for that and just deploy an App Engine. Now, let's say you like containers. Again, I love containers. A year ago, I didn't know what they were. I was a little apprehensive. I love containers because it adds this step here in the middle. So here you have your container registry. Here, this is kind of like a registry of versioned containers. We're all like, okay, here's my version 1.1 of this app. Here's my version 1.2 of my app. So you can at any point go into that registry of built containers and just say, now push this out, version 1.2, for example. Or you can say things like, actually, we had version 1.2. Now we built a brand new version 2.0. We're a little scared. We changed a lot of stuff. Well, now we have the container in version 1.2. We have the container in version 2.0. Let's go easy here. Let's just send 1% of our traffic to the new container that is version 2.0. 1%, and just check the error messages that come in. Check the support cases that come in through our support channel. If that's okay, we can maybe increase it to 10% as it runs on the new container, and then eventually ramp it up and eventually cut over completely to the new container. Also, containers, of course, are as we talked about before, they're easy to move between environments. So developers love them. Developers like them, and DevOps people tend to love containers. And that, of course, is because in the bad old days when I worked in startups, oh my gosh, 20 years ago, this happened all the time. Here's what happened. Martin sat down, I sat down, wrote my code. Everything worked great on my developer machine. I deployed it to production. Everything broke. Because, of course, I was relying, my code was relying on this one particular version of one particular library, something weird like that. Or maybe the Java version up in production was slightly different than the Java version on my machine. That one happened a number of times, actually. With a container, you put your application code into the container and you put all the dependencies and exactly what version of Java you're running, or Node or Python or what have you, exactly what version of each library you're running. We love containers. All right, so let's talk about what might an architecture look like if we're developing an API instead. So, for example, this could be, let's say your organization has a mobile app and it needs some sort of backend. Or it could be a web front end, and you need to put that as a REST API or something in front of your database so that your web application can talk to it. Here's an example of an architecture. So rich applications, you have the users out here, they're on mobile devices or on web applications. You could, if you want to, you don't have to. Actually, this step, I usually don't use this step, but you could put a load balancer in front of it if you want to. I would put Cloud Run or App Engine there as the computing layer and as the authentication layer. And then, because these are stateless, so Cloud Run, between invocations, this Cloud Run box here doesn't remember state, it doesn't remember sessions, it doesn't, it's very, very simple. And that means that Google can easily spin up new ones, new instances of this for you when your traffic increases. Well, as these are stateless, these compute boxes here, Cloud Run and App Engine, state must live somewhere, right? And that's where we put this in Firestore if we want to have a NoSQL experience for the developers, or Cloud SQL if we have developers who want to use Postgres or MySQL, or if you need SQL but strong guarantees around and replicas all over the world, but still strong consistency guarantees, you could use Cloud Spanner. So this is a fairly typical setup for that. Now, a lot of applications are built like this. And I mentioned before, my hobby application, I built this Cloud Run here, right? So, because it's not that complicated what it does. But often in an organization, as you start building out, you get more and more complex, multiple applications that need to talk to each other. And this is where you might get to the point of you're having multiple services, or you might even have many, many services, and you might call them microservices. How would you set that up serverlessly? Here's an example. We have 4 Cloud Run services here, and they can talk to each other. They would, of course, get calls from a user who's who I accidentally left off of this slide. Sorry about that. They would get 1 or 2 of these services would get calls from the outside, and then they would potentially call each other synchronously or preferably asynchronously, because that is more robust. These microservices can talk to each other. You could have one team assigned to work on each service. So something is broken in this service. Okay, we know that we go to Mary's team. They are the expert in this service. They can build that. As long as they don't change the interface to the other services, they can do whatever they want inside their own service. And then we can branch out to non-serverless, because there are still applications, existing legacy applications that we can't run serverlessly. And of course, as always, in the previous example too, right, we must have some sort of persistence. And that persistence is not in the compute layer, because that's not a scalable way of building things. The scalable way of building it is to have the persistence off in its own, on its own tier. And that's where we use Firestore, MySQL, or Postgres, or Cloud Spanner here, or files, or there are a few more options, but these are the main ones. Okay, so far so good. These are fairly simple applications that a small-ish organization would set up. But as your organization grows, you will pretty soon start to hit another use case. And I'm sure many of you have seen this already. For example, you get a requirement like every hour on the hour, we get a file of analytics, or we get a file with products, or we get a file of point of sales data or order data. We get a file of a bunch of records every hour on the hour. We need to analyze that, crunch that, and put it in some analytics data warehouse. And of course, you know how this works, right? You're a small organization, you get 1,000 records every hour. That's easy to do, easy to write up on your laptop, easy to run it on your laptop. It works great. You get 10,000 records every hour, you get 100,000, you get many, many records. And all of a sudden, this becomes a lot harder to solve, because if you have millions of records coming in, or even tens of thousands, what happens if the import breaks in the middle? How do you know where it broke? Do you go back, and how do you know where to retry? You don't want to do duplicate inserts, all that stuff. This actually becomes a hard problem, doing it at scale and reliably. And this is where serverless computing comes in. So you might have like data coming in from, this could be a file being dropped in. So you have various numbers that come in, and they need to perhaps be converted. Maybe we all need to divide them by 10. Maybe we need to package them, group them up. Maybe we need to validate, filter them. Maybe we need to calculate an average. Maybe we need to enhance this data that comes in somehow. Maybe it's text data that comes in and we need to enhance it with translations, for example. So serverless is great for this. What I usually do for this kind of data ETL is drop the file into cloud storage. So this is your storage area for files in your Google Cloud project. Drop the file in there. It can have 10 records or 10 million records, it doesn't matter, because the next step is that you can automatically transform this into PubSub messages. So what happens here is that your 10 million records are dropped in here, and automatically that is transformed into 10 million PubSub messages. Why break it up like that? Here's why. Those 10 million messages go over to your data transformation layer. I would typically use Cloud Run here because Cloud Run scales very well, and each container can run many of these, it can process many of these messages in parallel. So Cloud Run. Yeah, why just send 10 million messages of one row each? Because the person who writes this code will thank you, because it is far easier to write code to transform, convert, package, enhance data when you get one at a time. Anybody could write that code, very simple. Then to write, you get a big blob of 10 million and it might break in the middle. So this code becomes very simple to write. And if there's a failure, then the only responsibility of the app developer here is to make sure that if there's a failure, you return an error code. You do not return 200 OK. 200 OK is your way of saying, okay, I did it, I'm good. Instead, you return an error code, like 500 internal server error, or 404 not found, or some other code. And that means that PubSub now knows that your code has not handled it, and it will retry. And it will do all those nice things like exponential backoff and all that good stuff. So eventually, hopefully your data is all pushed through. And you don't have to deal with the situation of half the records were processed and the other half weren't because of some transient error. Yeah, and then in Cloud Run, you would then store this data, for example, in BigQuery after you crunched it or enhanced it. And BigQuery or MySQL or another database. BigQuery is typically used for these use cases because it is you sort of write once where you can only append data, you can't modify data. And that means that BigQuery is real because it doesn't have to deal with like updates and read-write contention and that stuff. BigQuery is really good at running SQL queries across huge data sets. So data processing, this is a simple use, I should say, a common use case. All right. Another use case that we often have that I've seen a lot of people do is automation, various types of automation in the cloud. So this could be, you could have various sources out here, like mobile or web clients, various APIs, GCP services. Actually, one use case that I should have included here that I didn't is IoT. Very common to have some IoT devices out here. Perhaps you have 1,000 temperature sensors that send, every 10 minutes, they send temperature up into the cloud. Now, it's very important that for IoT use cases or mobile web use cases or APIs, that things aren't down. Transient errors should not be noticeable to the people in the green box here. So typically what is done, you either make a pub/sub call here, generate pub/sub that goes to, so it's asynchronous. So it goes to Cloud Run or Cloud Functions. Or you can, I've seen many people do in IoT space, they directly call a Cloud Function. And then the Cloud Function or Cloud Run then does something with the data, crunches it. Maybe I've seen one use case where an IoT vendor, all they did was in the Cloud Function, they got temperature data from the field. All they did in the Cloud Function was just munge the data a little bit so that their database over here would understand it. So it became just the right format, converted time zones, a few simple things like that. And then asynchronously, you could feed it onto other services through pub/sub, or you can just skip pub/sub if you don't want to do it asynchronously. If you want to do it synchronously, you can skip this and just go ahead and for example, insert that IoT data into your database. And that brings us to a similar use case to this. And this is that glue use case we talked about before. So often you have things like, I've seen, for example, one customer in the UK, they were dealing with, it was kind of an IoT-like use case, or yeah, it was, I would call it an IoT use case. The IoT devices created Firebase records, records in the Firebase real-time database or in the Firestore database. So then you could set things up so that whenever a record is created out here, your Cloud Function is called. And your Cloud Function here is the glue that puts this together. So whenever something happens IoT-wise, then take some other action out here in some other cloud service. I've also seen, this is actually a very interesting use case, a big media company. They had set things up so that whenever somebody created a new cloud project, they ran some code here as a Cloud Function just to make sure that all the security settings were correct and change them if they weren't, and just some code here that managed the new project so that central corporate IT could have a bird's eye view of all the projects that were created, how many projects were created per day, who's creating them, that sort of thing. For compliance, this kind of glue is great. And with that, I've gone through the use cases, and I've gone through what I wanted to talk about here. I'm going to skip out of my slide here and stop sharing my screen.